In this example, we're going to find the inverse function of f of x equals 3x cubed minus 7 over 4 plus 5. There are a few steps that must be taken in order to properly find the inverse of the function. The first step is to replace f of x with y. So I'm going to do that here. You get y equals 3x cubed minus 7 over 4 plus 5. The second step is to swap x and y. So by doing that, we get x equals 3y cubed minus 7 over 4 plus 5. The third step is to now isolate for your y. So in this case, the first step is to move this 5 over. So we get x minus 5 equals 3y cubed minus 7 over 4. Now let's multiply both sides by 4. We get 4x minus 20 equals 3y cubed minus 7. Now I'm going to move this 7 to the other side. I get 4x minus 20 plus 7 is going to give me minus 13 equals 3y cubed. Now let's divide both sides by 3. So we get 4x minus 13 over 3 equals y cubed. So if I take both sides to the power of 1 over 3, I get the following. I get 4x minus 13 over 3 to the 1/3 equals y. So the last step is to replace y with f inverse x. So we get f inverse x equals 4x minus 13 over 3 to the power of 1/3. So in summary, we took our function and we replaced f of x with y, and then we swapped x and y, because the inverse function essentially switches your independent variable with your dependent variable. So we don't want to do all of our algebra having an f of x in there. So having a y makes it a lot simpler and less confusing. And then you isolate for your y so that you actually have your new function. And then once you have your new function here, you can replace your y with f inverse x. To graphically show what was going on here, this is our original function, and this is our inverse function. And all we did was we swapped x and y values. So when you swap x and y, you are effectively just reflecting your graph about the line y equals x. So whatever y coordinate you had initially, so let's say this is the coordinate 0, 3.2. This corresponding coordinate becomes 3.20. So every x and y coordinate is flipped.